Good morning, good afternoon, good evening. No matter where you are, we are so glad that you took the time out of your schedule to join us today. It's going to be a fun one today, folks. We've got an exciting time with some incredible speakers. So, with that, let's just get the show underway. My name is Daryl Prale. I'm going to be your host today. I'm going to be the fellow who accepts your questions and gets them to the panelists. I'll also be the one who will kind of act as arbitrator if there's any kind of challenges of opinions, shall we say. Think of me as your AM talk show host. But the real expertise are in the three individuals you see on your screen here: Larry Strickland, Russ Tubner, and Scott Quillisi. And these are three incredibly bright, capable, accomplished individuals who want to share with you some knowledge today. Three different ways that you may not have considered on how to optimize your data and your transactions. So the joy of doing a webinar like this is not only do you get to learn from their experience and their knowledge, but you also get to ask them questions. There's two ways you can do that. As you see in the slide in front of you, you each have a control panel. It's located in your upper right-hand corner. And what you need to do is go to the questions tab of that control panel. Any questions you put there, we'll see, and then we'll get them to the panelists. Similarly, though, if you're a social media maven, you can go to Twitter, and all we suggest you do is reference #optimization. And if you do that, we'll be tracking along there as well. So not just questions, but comment, feedback, opinions. Let's make this a real-time conversation between you and our guest speakers. Mention myself, that's me, but really, let's talk about the experts. Larry Strickland is Chief Products Officer responsible for product direction as DataKinetics branches out into important new business segments. Prior to joining DataKinetics, Larry was CTO and VP Product Management for Natural Convergence, a startup where his technical background and market astuteness was instrumental in developing key product differentiators and forging important business partnerships for the company. Previously, he held various management positions with Nortel Networks during that company's period of high growth and market dominance. Larry holds a PhD and a BE in electrical engineering from the University of Melbourne in Australia. And by the way, he's a volunteer firefighter. Larry, welcome to the show.
Thanks, Daryl. Pleased to be here.
Great. Next up is Russ Tubner. Let me tell you a little about him. He's the CEO of HostBridge Technology. Russ is a seasoned inventor and entrepreneur in the software industry. Over the last 30-plus years, Russ has applied his creative energies to solving difficult problems associated with integrating large-scale IBM systems and various emerging technologies. HostBridge's flagship product is used by large organizations to bridge the gap between web-based applications and high-value System Z applications. Russ has been a contributing author to various technical publications and is the co-author of U.S. Patent number 6981257, pertaining to XML enablement and KICS applications. Russ, welcome to the show.
Daryl, thank you very much. It's a pleasure.
Awesome. And next up is Scott. Scott is not only a good-looking man, as you can see in front of you, he's also the founder and CEO of SQData, an Addison, Texas-based software company that specializes in high-performance data movement and changed data capture, CDC, for mainframe and distributed databases. Scott has over 30 years of database experience and is considered an expert in large-scale database replication strategy and deployment. Scott has managed numerous data integration projects, most of which involve the near real-time change data capture and high-volume data movement. Scott, welcome to the show.
Thanks, Daryl. Thanks for having me today.
All right. So with that said, folks, the way the format is going to work here is we're going to kind of set the stage a little bit, just to give context to what is a transaction. And then we're going to ask each of the three experts to talk about their respective technologies and how they help achieve the goal of, optimizing all that data. So you can actually hear three different ways of doing it you may not have considered. And then we'll wrap it up again, bring it back and kind of recap what you just heard and maybe bring all the pieces together in one single slide of how all three might work together complementary. So after that, we'll go to Q&A. Remember, it's on Twitter, #optimization, or in your control panel. Send us a question. That's how it's going to work. But to set the stage, Larry, I'm going to ask you just to help us understand what is a transaction. And for all of our panelists today, because I'm the guy behind the controls, just tell me when you want me to move the slide, and I'll make sure the slide progresses. Larry, the floor is yours.
Okay, thanks, Daryl. One of the reasons we like to start off with what is a transaction is because the term transaction is used many times in many different places and actually in many different contexts. So when we're talking about a transaction, we're generally talking about a business transaction. So something that involves either the exchange of transfer of goods, services, and typically so that everything's whole, some kind of funds to pay for those. So often we think of this in the instance of buying or selling something, and it really is all about day-to-day business. What we find in today's world is another term for transaction is a database transaction. And what we find is that a business transaction will often result in many database transactions, typically at least one, but more normally many transactions that will hit the database as a result of a single business transaction. So what are the typical steps that make up a transaction? Well, there's a number of them. The first one is the initiation of the transaction. This is normally from some kind of client. It might be from another enterprise, a user through a mobile device, a point-of-sale terminal, or a regular PC. This transaction request normally comes in through some kind of server, often a front-end server, often a distributed box, although not necessarily always. This will receive the transaction and may actually process part of the transaction, if not all of the transaction at that point in time. It may also pass requests back to a back-end server, and in this slide we're showing that as a mainframe. That's the environment we're most familiar with. So actually that transaction going back to the mainframe. Within the mainframe, there's a number of things that happen. There's the integration to that front end that's allowing you to receive that transaction. And then that transaction would be processed. So this could be processed in real time through online transaction processing that may result in an immediate response being sent back to the client. Certainly an acknowledgement would be sent back to the client. However, much of the transactions that are discussed before may occur after the fact. Visa processing can occur several days after the actual initial transaction takes place, and that'll often take place in a batch process that will run on the back end or in the mainframe during the course of normal business. The result of this transaction will cause data to be either updated, added, or deleted even. And it's that process of updating the data is often a series of database transactions that can be across multiple different data sources. Finally, once data has been created, often there's a need to replicate that data. So that data may be replicated for redundancy purposes. It may be replicated off to a data warehouse or up into a cloud. It may also be replicated off to a business analytics engine for the purposes of understanding how well a business is doing. So there are many steps involved in a transaction. What seems like a simple start can become a lot more complicated. With these transactions, there are a number of business challenges. First off, the market in general, the volume of transactions is going up. There are more and more transactions happening. That's business transactions. The value of each transaction is actually going down. So for the same volume of revenue, we're seeing an even higher increase in transactions. The distance between the data needed for transaction and the source of the request is often becoming greater. Businesses are operating globally now and have data centers throughout the world. And often the client may be reaching through for a business transaction that may be occurring in a completely different part of the world. And we need to deal with the fact that that data is no longer close to the user or may not be close to the user. The other thing is that many of these transactions are now coming from newer type devices, mobile source data, and mobile source as an example. And as a result, the number of transactions occurring between mainframe data and mobile is going up and up. As was discussed earlier, each transaction requires several database transactions and may initiate several follow-on transactions, the visa reconciliation being a good example of that. So each, as the volume of transactions go up, obviously the transactions within the database systems goes up as well. And any follow-on work that needs to happen, such as replication of data, is also going up. Businesses operate on a 7/24 basis. They need to know their data is always available, always ready for their customers and partners and the like. Often the way this is done is through replication. So now we have a challenge where we need to make sure the data in all locations is in sync so that we're not ending up with transactions that are performed on old data. So one of the reasons that DataKinetics, HostBridge, and SQData have decided to work together is we actually have discovered that we optimize various different areas in that transaction process. So the purpose of this slide is to give you an idea where each of the companies plays before we get into the guts of the optimization discussion. So first off, talking about Tablebase, which is a DataKinetics product. Tablebase is used to optimize data access in both batch and online transaction environments. It has a sister product called NetTables, which performs a similar function but on distributed applications. HostBridge is a best-in-class player in terms of providing integration optimization between that distributed application and that online transaction environment. And it also, gives that ability to offer those mainframe services to the outside world. Lastly, but certainly not least, is SQData. SQData is an expert in replication, is able to provide that replication needed between different data sources and destinations, whether it be to push the data off into the cloud, to a data warehouse, to a business analytics engine, or simply provide replication such that we can provide a high availability scenario. So that's how all the companies fit, and hopefully they'll provide the appropriate context for the next few slides.
All right, so that tells you how everything works together. Thank you, Larry. I really appreciate your setting the stage for us. Gives you the definition of what we're talking about here for context. So with that said, let's start off with our first company. We're going to start off with the hosts of the webinar, DataKinetics. Just reminding you again, though, at this time that you can submit your questions in the control panel using questions. Just go there, submit it away. And we like commentary and feedback, too. It doesn't have to be a question, so knock yourself out. And you can also do it on Twitter with hash optimization. So now that we've got that housekeeping out of the way, Larry, back to you. Talk to us about DataKinetics. Tell me when to change those slides, and let's share some knowledge.
Okay, thanks, Daryl. So the strength of Tablebase, DataKinetics' flagship product, is its ability to provide access to data in the fastest possible manner. So it does this by putting data in memory. And historically, that was the key to giving fast access to data, is to put it in memory rather than keeping it on the disk, particularly with the advent of virtual memory and other advancements in the mainframe. This was very effective at providing very fast access to data. And we have stories of massive reductions in runtime as a result of that. However, today, most products have caught up to that concept of putting data in memory. DB2 talks about buffers. vSAM talks about, has LSR for buffering. So there are many techniques to put data in memory. But there's a second part to the problem. Even once you put it in memory, you need a very fast route to access it. You need to execute the fewest possible machine cycles in order to get access to data. And this is, again, where Tablebase excels. So Tablebase uses the shortest possible access to that data, which can greatly reduce a length of runtime of a program, the amount of CPU used, when data is accessed frequently. So this is where in-memory tables and Tablebase excel. So that is the reason why you would consider Tablebase. And we'll talk a bit more about some of the performance that brings in a few more slides. So where does Tablebase get used? So one of the areas Tablebase gets used is in optimizing batch processing. it doesn't matter where the data currently resides, whether it be flat files, DB2, VSAM, IMS. There is a certain portion of that data that is accessed extremely frequently. And actually moving the extremely frequently accessed data into Tablebase and allowing for the very fast access of Tablebase can drastically improve the performance. So this is where Tablebase gets used. The process is relatively straightforward. Data is moved, the data that is accessed most frequently, which is normally reference data. It can be other types of data, but typically reference data. Reference data is moved into Tablebase to optimize access to that data and therefore improve the batch process. Okay. So Tablebase also gets used in online transaction processing. In that case, again, data is going to be taken from its normal data storage, DB2, VSAM, IMS, pulled into Tablebase, and then accessed from the KICS environment, and again, in a way that's much faster than would be to access it in the other mechanisms, and as a result, speed up the online transaction processing. This can be due to the fact that there's a capacity issue in the KICS environment, or it could be to the fact that there is a response time or a need for a faster response time in that environment. Also, one of the things we find is that often applications built in the distributed world, built in Java, are often not considerate about how they're retrieving data from the mainframe. One advantage of Tablebase in this environment is Tablebase can reduce the load on the mainframe for those requests coming in from the Java environment. It's not going to do anything to improve the performance of that Java environment. What it will do is reduce the load or the CPU required in that environment on the mainframe. And in fact, this is an extension to the Tablebase product. So Java to DB2 optimizer is what we call it. It incorporates Tablebase in its solution, and it gives you a much faster access from Java to that DB2 environment. So one example of a customer using Tablebase. So this was a case where a customer had a COBOL program. It was using internal table, and binary search process. So that's the COBOL internal table. Turned out that the search being used in this COBOL program was used about 1.25 million times and had 4 different searches in it, so in the order of 5 million executions. This program took well over an hour to execute. So the solution was to put those 4 searches, specifically that table, into Tablebase and enable the 4 searches to run against Tablebase rather than running in the COBOL program directly. And the result was a 99.98% reduction in CPU seconds because Tablebase was just that much faster. So that program that was taking over an hour to run then reduced to a minute. Now, less than a minute. That's a pretty extreme example. We don't always see such drastic performance improvements, but it is an example of the types of scenarios we do run across when we're deploying Tablebase. So how does DataKinetics help their customers? Well, we help by optimizing transactions, specifically their access to data, the speed at which they can access the data. This has a number of impacts. Ability to increase profits. So simply by going through and optimizing processing, you can decrease the cost on the per transaction basis and therefore improve the profit margin within a company. Reducing costs, obviously reducing costs is part of this. So by reducing CPU or reducing elapsed time or avoiding a hardware upgrade to need to address these things, we can reduce costs. Increased capacity. Well, obviously increased capacity comes from the fact that if your transactions are taking less time, you can execute more transactions in a period of time, or with the same hardware infrastructure, you can perform more transactions. So one of the things we haven't talked about much is some of the flexibility that Tablebase offers. So one of the ways to make an application very flexible is to remove much of the business logic from the code and put it into rules in a database. One of the challenges with that is rules that are driving an application need to be retrieved very regularly. And if they're in a database, this can actually cause you quite a lot of grief because the time taken to retrieve the rules takes too long. One of the advantages of Tablebase is because it is so fast to access. By putting rules in Tablebase rather than in the program, you can actually not have that speed hit but still have the flexibility of being able to use a rules-based engine to drive your business processing. And I think that should be my last slide, Daryl.
That is your last slide. And look at that. You nailed your 10 minutes. And just to remind folks, we're giving each speaker here 10 minutes to talk about their unique technology and how it helps the optimization. So you get a quick hit. And if you want to know more, you can ask questions here, or you'll be able to follow up with each of the presenters afterwards. And we're going to give you that contact information after all three presenters have given their little overview. So stay tuned for that. One thing we're always asked when we do these shows is we're asked, are the slides available? Is this being recorded? Can I share this? The answer is the slides will be made available to you. Yes, it is being recorded. So within a couple of days of the show completing, you'll get a link from us via email to the slides, to the on-demand playback of the webinar, and you can share that with whomever you want to. So that's fantastic. Next up, though, will be HostBridge. So to bring up that, I'm going to call upon our HostBridge expert. All right, the show's yours. Take it away.
Daryl, thank you very much. I appreciate the opportunity to be here today and tell you everyone a little bit about HostBridge technology. I know that we have various customers around the world, but we're always interested in making the acquaintance of new customers. And so I'd like to introduce ourselves by simply saying we're in the business of providing integration software, and more specifically what we like to call precision integration software for System Z. We were founded in 2000 when myself and Scott Glenn, my co-founder, decided that it was time to invent a new breed of integration software by exploiting certain features that IBM was preparing to come out with in CICS Transaction Server version 1. Back in that time frame, 1999 to 2000, IBM turned a big corner from what they used to call CICS version 4 to CICS Transaction Server version 1. And there were a lot of new interfaces under the covers of CICS Transaction Server that gave us the opportunity to completely rethink integration, with our first target being how can we rethink application integration without screen scraping. And so that was really where the patent number, Daryl, that you very adroitly walked through came from. How can we do XML enablement of CICS transactions in a way that eliminates screen scraping? But all of that being good technology, it has to be done for a real business benefit. And so what we've always had a passion for was helping customers use technology to save time, cut costs, or generate revenue. And beyond that, what really gets us excited around the office is being able to work with customers to do the hard stuff. Customers, large organizations, have been working on integration projects for a long time. And frankly, all the easy stuff is done. The stuff that remains are the harder, more complex issues, whether they are complex by virtue of the nature of the application or the actual nature of the integration required. We serve large organizations worldwide. Here's a list of them. There are many others, and we're very thankful to our customers for not only embracing our technology, but also acting as references on our behalf. Another key part of our business equation are our partners. And I would first of all like to say that IBM, through various product groups such as the ZOS group, the LE group, and certainly the CICS group, have been wonderful partners to us and allow us to participate in all sorts of great opportunities before new versions of CICS or new versions of ZOS are announced, so that we can make sure that our products not just are compatible, but actually exploit those features. Let's go to the next slide. Larry has already touched on a couple of these things in his comments, but we would just like to echo them, and that is that operational efficiency is paramount. I have the privilege of meeting with a lot of customers around the country, around the U.S., and around the world, and if there is one thing that I always come back with, it's that operational efficiency is number one. Everyone's wanting to respond to competitive pressures in their industry, and for those of you who have extremely high volumes of business, you're looking for ways to lower the incremental cost of high volume application processing. You're looking for ways to bend the cost curve down as the transaction volume goes up. But not only is operational efficiency of paramount importance, at the same time, so is service and data agility. And that list of acronyms or pseudo words underneath it, like web, mobile, SOA, cloud, AJAX, whatever, that's just a smattering. Those are today's themes that we are all finding ourselves needing to be aware of and sensitive to and build things with or for. I'm proud to say that now that JSON is starting to get a little more press, a little more notoriety in mainframe circles, I'm very proud to say that our customers have been using not only XML but also JSON as a way to express data out of System Z for, I guess, going on about 6 years now. So we're happy that our customers can use our product to stay ahead. We also spend a lot of time, when you look at how we describe our value proposition, it always has and, not or. And we think that's critical. Organizations need to extract proven value of their existing System Z apps and data. They need to integrate them with the widest array of non-System Z apps and interfaces. And there's the operative word, and. They have to do it in a way that squeezes cost and MIPS out of every process. Now, our approach to doing this is the HostBridge product line. The flagship product of HostBridge is also known as HostBridge. We often refer to it as the integration engine. It is the engine that runs on System Z, usually or most always inside of Kix, and it is a 100% zip-enabled engine that is oriented toward optimizing the movement of instructions, the invocation of little program artifacts. Because when we thought about System Z applications 20 years ago, we might have conceived them in a certain way, that a customer would use transaction A, then transaction B, and then C. But now they understand the business case or the business problem much differently. And so the orchestration engine, the integration engine running in Kix, gives them the flexibility to be able to expose as a composite web service something that is comprised of various bits of programmatic logic or existing data. HostBridge Wire, it was specifically developed for those customers who need to present a completely different user interface to their existing System Z applications. Many of our customers interact with our product purely on a web services basis, where what's being transferred in and out from our product is JSON or XML or other types of data-oriented artifacts. But some of our customers need the interface. The interface is extremely important. So HostBridge Wire is our product that lets them do that in the most robust and simple way possible. We've specifically built it to where users can adapt the user interface based on the delivery channel, whether that's an iPad, a mobile cell device, a full-blown web browser, or whatever. HostBridge Socket Support is the newest member of the HostBridge family. It was specifically developed as a result of some work we did with a couple of customers, one domestically, one internationally, and it was to help them really lower the cost of integration. Again, large organizations who have extremely high transaction volumes have often developed their own in-house socket-based applications in order to facilitate the massive flow of transactions in and out of the System Z. But along with that came, unfortunately, a lot of CPU consumption sometimes to facilitate the flow of data in and out. So HostBridge Socket Support is a brand new product that allows us to exploit extremely modern System Z and CICS capabilities, including OTE, that allows the organizations to radically lower the cost of socket-based applications. Let's go on to the next slide. Some of the customers that we like to highlight really use various aspects of our product. The first one of course, is Navy Federal Credit Union. They use our product as part of their edge connector between their System Z-based core banking applications and a myriad of distributed devices, anywhere from ATMs in all 24 time zones to browsers to any sort of tablet devices, you name it. Their customers are mobile, they are global, and they need to be able to access their account information in a variety of ways. So we're thrilled that we're part of their boundary, their edge connector. The second customer being highlighted here comes from the insurance industry, and they used our product to be able to create very lightweight JavaScript and XML-based web services. Their objective was to be able to integrate their existing investment in System Z apps and data with a whole new web-based application infrastructure from computer sciences. The key thing they wanted was user productivity and a streamlined web services deployment environment. Of course, another great customer that we're proud to serve is Nissan. Their finance division uses HostBridge to implement RESTful web services to facilitate the leasing of vehicles within their dealer network in North America. State of Arizona uses HostBridge in yet another way. They're using HostBridge in the healthcare industry to act as the intermediary or the facilitator in tying together 1.3 million Medicaid members in the state of Arizona with 34,000 healthcare providers. So HostBridge is involved in the delivery of apps and data in that context. And then finally, as a representative customer would be KPT CPT. This is a customer that has done some wonderfully, just delightful projects where they've taken their existing CA Ideal applications and CA Datacom database data, and they have figured out and come up with new innovative ways to extend those apps and that data to 7 million residents within the country via a dedicated portal and cloud platform. So those are some of the things that our customers have done with the product. Let's move on. I suppose to describe the business benefits, what I just wanted to summarize with were to say that what we seek to provide you and to all of our customers is a trusted, scalable product, or really a collection of products to integrate System Z apps and data with the rest of the world, whatever that may look like for you. We want to help you exploit innovative techniques and modern System Z features to do two things. We want to drive up the integration quality and System Z value, and we want to help you drive down what we call the integration friction and System Z costs. We want it to be simple to implement, fast to deploy, and to make sure it's priced such that you have an easily attainable ROI. And perhaps if there's one thing we try to get across with our customers or make sure they know is that we get it, that System Z integration is always about helping you move your business forward. So Daryl, I'll close there and look forward to the Q&A.
Awesome. Thanks a lot, Ross. So there you go, folks. You've now heard two different technologies working together, stressing that optimization thing. That's phenomenal. Speaking of optimization, you can comment on the conversation by going to Twitter using #optimization, or you can submit your questions in real time in the control panel. But next up, to round out the triumvirate of opportunities here to increase your optimization around data and transactions, we have Scott from SQData. So Scott, with that said, the floor is yours. Just tell me when to change the slide.
Thanks, Daryl, and I'd like to thank everybody for joining this morning. So far, the content's been great. Let's see if I can keep it up. At SQData, we were also founded in 2000, similar to what Russ did with HostBridge, and our mission was to provide an enterprise-class change data capture and ETL framework, and we've accomplished that over the last 12 years. Our technology really centers around the ability to capture changes the instant they occur, and from there, there's a lot of things you can do with that data. Typically, data warehousing, maybe high availability, and we've got some examples here in just a few minutes. Next slide, Russ. From there, we can meet a list of data challenges that most corporations have. First one being continuous availability. We're seeing more and more of that, where you're using replication to keep 2 or more data centers in sync, or critical applications in sync. So if one side goes down, then they can pick up and run from the surviving location. More often lately, we've seen a lot of active-active replication, where you have 2 sides going both ways, bidirectional replication, and at a high rate of speed. These are typically larger companies that do this, but we're even seeing the medium size and small size companies do the exact same thing. The second challenge you use change data capture for is to, say, populate a data warehouse or BI type application. We see a lot of that in addition to the continuous availability, where key information needs to be sent to a business intelligence data warehouse the second it happens. And that's very, very important, so you have current information. The latency overall, what I mean by latency is the time the source data was updated until the time it was put into one or more target destinations is sub-second, typically 1/3 of a second, say 300 milliseconds, 200 milliseconds is what we see on the average. The next thing you can use change data capture for is real-time detection of certain business events. We have a healthcare customer that watches any claim that comes through. They're replicating their claims to an ODS, and I think we have a slide on that later. Then while they're replicating this, they're looking at their claim information, and if something comes in over $500,000 on a claim, then there's an XML message that's sent to a fraud application through a queue, and SQData does that as well. But the key is really detecting that happened, the instant it happened, and then taking action on that. The other piece, and I'm sure it's listed here, is application migration. And these are customers that have an old legacy application that they're migrating to newer technology. And rather than do the one-time shot, they do it in phases. So this allows you to keep the old database and the new database in sync during the transition period. It takes a lot of pressure off the application team. So as I mentioned earlier, we like to think of SQData as a Swiss Army knife of data integration tools. And it does the data part of it very, very well, very efficiently, and with a very light footprint. So there's not a lot of CPU cycles involved. But it's pretty much a plug-and-play type of setup where you choose the source, choose your targets, define your transformations, your business logic, and have at it. I mean, it's very, very, it's designed to run 24/7, 365, and again, with very little footprint and sub-second latency. When I talk about latency, it's the time of the change actually occurring in a database until it's moved to or replicated to other targets. And we see anywhere from 200 to 300 millisecond latency on the average. So it's definitely sub-second, and that's what customers are looking for these days. Here are some customer examples of where they've used replication. These are somewhat complicated, but you can see what customers are using SQData for, change data capture and replication more specifically. In the first case, we've got a very large bank that is doing three-way active-active replication. They have 3 data centers, one in Toronto, one in Montreal, and one in Vancouver. And they're keeping all 3 of these systems, so these databases, they're running critical applications in sync. So at any given time, within a second or so, all 3 of those data centers are in sync. So if one goes down, they can fail over to the other one and pick up right where they left off without losing any data. This was somewhat complicated. We rarely see 3-way active-active, but we actually had a call earlier this week with another customer who is looking at that as well, but they're including non-DB2 type data. They're looking at Oracle, DB2, and SQL Server, all 3-way active-active. The second customer challenge is taking multiple databases of different types and consolidating them into one near real time. This happens to be a healthcare company that have 4 different claim systems, completely different claim systems. Well, that makes it very difficult on customer service and even their web interface to figure out which system and how to use it and so on. So what they use SQData for is to capture the changes from all 4 of those systems and replicate those to a single operational data store, or ODS is what we refer to that as, near real time. So everybody can work off a claim. As you don't have to worry about the format, the original format. It's in the ODS format, so customer service can be well prepared, provide better service, and if you're coming in through a web portal, then you have very accurate information up to a second or so latency. Their objective is to replace some of these claim systems with new technology, and this replication allows them to do that in a phased approach so nobody notices. And most importantly, the customers don't notice, which is the ideal situation. Okay, well, to summarize, again, SQData being a Swiss Army knife for data integration, data replication tools, you can make sure your data is always in sync, use it for high availability, continuous availability, event publishing, business event publishing, making sure that data is delivered in a timely manner to your BI apps, that it integrates between older applications and newer applications from a data perspective. And you want all of that within a single package, and that's what we offer. So again, I appreciate everybody joining and listening to us today, and I hope you got something out of it. Daryl, I'll turn it back over to you.
Thank you so much, Scott. I do appreciate the thoroughness of that. To bring us back full circle, I'm going to bring Larry back on, who's just going to summarize exactly what you just heard here. Larry, the floor is yours.
Okay, so bringing back actually a combination of 2 slides we showed earlier. One looking at the transactions and the other one looking at where the companies fit. So just to summarize, transaction, we'll start at a client, go to some kind of front end or distributed application, which will then move into a back office, often a mainframe application, for the transaction processing. The actual processing can occur over many days as a result of various processes need to run, including reconciliation and the like. The result of the transactions will generate a large number of data updates, inserts, or even deletes. And this data often needs to be distributed for a number of reasons, including data warehousing, business analytics, and replication for redundancy purposes. And to remind you, the 3 companies involved: HostBridge, which specializes in integration, table-based, ability to give very fast access to data, and SQData, able to provide a Swiss Army knife for data replication. Finally, to repeat things that we've been saying probably multiple times through this presentation, possibility of increasing profits by decreasing the cost of processing each transaction. Many companies will actually know their exact amount per transaction. The opportunity to reduce costs, whether this comes from reducing CPU and elapsed time and therefore the follow-on capacity requirements. Being able to increase capacity, specifically increase the number of transactions that the same system can process, giving you a faster and simpler solution, being able to change rules, not in the application, by changing business logic in an application, but by changing rules in a database, and also using rules, as in the case of SQData, to replicate between databases, or in HostBridge cases, using a similar construct to give you access to the mainframe services. Getting access to efficient analytics, being able to integrate that data across to different systems as required, or just get access to it. And lastly, flexibility. A lot of choices here in how you deliver data, where you deliver data, and how you get access to data. So many places you can optimize your transactions.
That's fantastic. Thank you, Larry, for bringing us back on that full circle. What we're going to do now, folks, is we're going to go into the Q&A section. So the questions have been coming in. We're grateful for those. Keep them coming. Again, Twitter, #optimization, or in your control panel. under the questions section. But in the meantime, let's get this going. So, Russ, I'm going to throw you the first question here. And I'm just going to paraphrase here. Russ, you're suggesting that System Z users can lower their cost of ownership by rethinking their approach to integration. Are you really seeing these savings in the field? So I guess they're a bit cynical. What's the scoop on that?
Yeah, well, I can understand. It's a good question, and I can understand why there is a bit of cynicism about this. But the answer is yes, and we have customer-generated data to back it up. There are at this point in time, our philosophy and the guidance that we give customers is pretty simple, and that is that if you look at the modern IBM System Z mainframe, you have general processors and you have specialty engines. And putting it even more bluntly, you have high-cost MIPS and low-cost MIPS. And customers, at least our set of customers, really don't have any problem, or the economics aren't that bad when they focus their high-value MIPS on high-value apps. However, when there are some real issues, cost issues associated when you use high-cost MIPS for integration or plumbing or data transport, however you want to describe it. So yes, as what we've seen is as organizations over the last few years have used our highly efficient integration engine and our zip enablement capabilities to serve as the boundary for their high-value apps, they really are able to bend the cost curve down. They really are able to lower the cost of integration and therefore significantly reduce the overall cost of System Z ownership. So yes.
So yes, that's awesome. All right, well, there you go, nice and simple. Scott, here's an interesting question for you. The question is, how does SQData compare performance-wise against other replication products? So any insights on that one you can share?
That's a great question. I guess the biggest differences, one is probably performance. As far as performance goes, we've never run across a replication solution that's faster or more efficient, which gets into the second piece, is efficiency. Our competitors, especially on the ZOS platform, typically use a lot of CPU, and as was mentioned earlier, cycles are not free. And so anything we can do to reduce the actual CPU consumption is a plus. The other piece, last but certainly not least, is the all-inclusive packaging, where everything comes as a single. It comes in a single package, so there's no a la carte pricing, and customers really appreciate that. Combined with the service and the actual support is what we do, so we're actually pretty good at it and seeing all the different situations. We provide the customers with the value of best practices so they can avoid the same mistakes that many people make with other tools.
Larry, got a tactical question here for you. It's very simple. They just want to know what sort of data is normally stored in Tablebase.
Okay, so I did mention that it's frequently accessed data. So often customers will ask us to move very large amount of data into Tablebase, which isn't necessarily the best thing to do. Typically it's small amounts of data, and that's because we're looking for records or data records that are read very frequently. Not tables that are read very frequently, because a large table we'd read frequently, but each record within that table will be read rarely. So what we are typically looking for is small tables that are read very frequently. It turns out that a classification of data that fits in this is what we call reference data. So the best example I've got of reference data is a state table. A state table would list every state in the US and maybe extend to have some provinces in Canada, for example. And that table very rarely gets updated. It's quite small, but every time you're validating an address, you're going to be reading that table. So it gets read very frequently, and every record in that table gets read very frequently. So that's an example of what sort of data really is best fit in.
Well, you must have got their attention because they followed on with this other same question here. Here we go, paraphrasing. So this is still for Larry. Wouldn't using buffers in DB2 be as effective as table-based since that puts the data in memory?
Unfortunately not. So moving data into buffers in DB2 is a very good way to improve performance, and particularly with DB2 version 10, you've got better controls over which tables end up in those buffers. And that does move data into memory, which does make it faster to access than trying to wait for the system to go back to the disk. However, table-based is still substantially faster than DB2. We've had actually IBM go in and optimize a table for access and then compare it to table-based. And table-based, it was more than 20 times faster than DB2 in retrieving the same data. So that gives you an example of why table-based is good for that frequently accessed data.
20 times is not insignificant, so I guess that answers the question. Scott, got a question here for you. Do you support active replication against different database types? And they're saying, for example, DB2 to Oracle, vice versa, etc.
Thanks for that question, Daryl. Yes, that's a good one that comes up quite often. Yes, we do support active replication between different database types. It's very common nowadays, especially with application migration, where you have an older database, say DB2 on ZOS, and a newer one in, say, Oracle or SQL Server on distributed, that you need to keep in sync both directions. We even have the ability to go, say, from relational back to IMS or vSAM, so we can go active between non-relational and relational as well. So yes, that's a very common requirement these days. Heterogeneous active.
All right, let me flip it back here to Russ for a second. Russ, you mentioned that one of the advantages of HostBridge is the speed to develop and the speed to deploy web services. They're wondering if you can maybe give them a little more detail around that.
Okay, yeah, I like the question. I think the speed of deployment comes out a couple of different ways. One is the speed of the deployment of integration. It first starts with, what do you have to know? What is an integration architect, an integration developer, or a web application developer really have to know? And so the first thing I would comment that lets our customers speed integration is that the only thing is how little they need to know, and that's really the remarkable thing. We provide an Eclipse plugin that will work with any Eclipse-based editor. That becomes the user interface, their palette, so to speak, for being able to author an integration process. And then, as I mentioned earlier, the integration language that we chose to use, a couple of years ago, we had a few people who kind of raised their eyebrows at us because they thought it seemed like an odd choice, and that was JavaScript. Now, however, there are more people who know JavaScript almost than any other. Probably it is the most widely known scripting language in the world. It is very difficult to do anything on the web, on any web page, without JavaScript being an active element of that interaction. And so we chose to use JavaScript, albeit a server-side implementation of JavaScript as a key part of our integration strategy. So as a result, we have customers whose web developers or integration service developers have never seen a mainframe. They would not know a System Z mainframe if they backed into it. But they are able to use the same base of knowledge and tools, such as Eclipse editors, such as JavaScript deployment methodologies, to not only create the client-side service, but also the web-side service. So we think it's that sort of an approach that is what allows organizations to speed the deployment of these web services. So I guess, Daryl, I'd highlight those two things.
Thank you. That's a great answer. Scott, I'm going to throw this one at you. The question is, what is the typical latency from when a source database is updated and when it has been applied to the target database? So pretty specific question.
Okay. Yeah, we discussed that briefly on my slides, but be glad to revisit. The average latency we see is anywhere from, say, 200 to 300 milliseconds, which is, say, a third of a second or less from when the actual data is changed in the source and delivered on the target side. Now, there can be some factors that affect that. For example, big units of work, it might take, a minute, 2 minutes before they actually do a commit. Then the latency would obviously be 2 minutes for the oldest record, just because we have to wait for a commit to come in before we can push the data downstream. So, but on the average for online transactions, you're definitely looking at sub-second, a third of a second, maybe half a second latency, which is pretty good.
Larry, you alluded to this in your last answer, but the questions come in is how much faster is table-based?
So that's like asking how long a piece of string is. So it depends on the circumstance. So the example I gave before was table-based for random access data was more than 20 times faster than DB2. So we often get used in that circumstance. We also often get used against VSAM datasets, used in replace of VSAM datasets. And when VSAM is much faster than DB2, as you can imagine, we see performance improvements of about a factor of 3. In the COBOL example I gave before, we saw a massive improvement, but that wasn't due to data access speeds. That was actually due to the search speed. So table-base's inbuilt ability to do searches extremely fast gives you very fast access to the data as a result of being able to do very effective searches. So, 3 examples where performance is quite astounding for table-base. Again, depends on the circumstance. But a good question. Typically, it is that question that we are answering for customers as we engage them for all the early part, is how much faster can we make their data.
Awesome.
Thanks for the question.
That's great. A good answer. We're going to give Russ the last question, but before I give it to him, just a reminder that the email addresses for all these individuals are on the screen in front of you. Please, please, please drop them a line if you have any questions for them. So, Russ, last question of the show. I think you mentioned that HostBridge doesn't rely on screen scraping. How does HostBridge do this? Why is this important in 30 seconds or less?
Oh, wow, 30 seconds or less. Put me to the test here. Well, screen scraping, that approach, that methodology has been with us for a long time. And screen scraping at its core is seeking to achieve or couple two processes, 2 programs on the basis of the row and column coordinates of the information on a screen space. So, for example, if your name is on row 3, column 5, and the consumer, the consuming application needs to know that is screen scraping. Because as a result, if some well-intentioned person moves where that data is, the integration breaks. And so what we did back in 2000, based upon the first version of CICS Transaction Server, is invent a methodology for exploiting a component of CICS called the bridge interface to allow organizations to interact to or with mainframe-based BMS-style screen-oriented applications and completely eliminate the row-column dependencies. So that's a key. It's a great question. It is something that we have gone into many organizations time and time again and showed them how they can not only improve the performance but also the fidelity of the integration by eliminating screen scraping.
Awesome answer. I'm not sure you stuck to your 30 seconds, but you were close, and I'm going to give you a B+ on effort. So well done on that one. Gentlemen, Larry, Russ, Scott, thank you so much for your time today. Everybody online, whether you're listening to this live or listening to this on the recording, please reach out to these gentlemen. Their email addresses you see here. They would love to talk to you more. Hopefully, we've given you 3 different ways that you may not have considered to optimize your data and your transactions. So don't be shy. The ball's in your court. With that all said, thanks for joining. Have a great day. We'll talk to you real soon. Take care.